The hum begins subtly, a low thrum that vibrates through the very ground beneath your feet, long before you ever glimpse the steel and glass behemoth on the horizon. This isn't just another industrial complex. It's a gateway, a hidden world where the ordinary transforms into the extraordinary. We consume its creations daily, spread them, dip into them, yet few ever truly consider the intricate alchemy that brings them to our tables. What if I told you that within these walls, a symphony of science and precision orchestrates the birth of one of the world's most ubiquitous condiments? A creamy, emulsified marvel that seems simple on the surface, yet conceals a manufacturing saga far more complex and fascinating than you could ever imagine. Imagine stepping through a portal, leaving behind the familiar world of grocery aisles and home kitchens, and entering a realm where raw ingredients are not merely mixed, but meticulously engineered. This is the heart of a high-tech factory, a place where the humble egg, oil, and vinegar undergo a transformation so profound, it redefines our understanding of food production. It's a journey into the unseen, a deep dive into the industrial mystery that cloaks the origins of everyday products. We are about to pull back the curtain to reveal the hidden processes, the ingenious machinery, and the unwavering dedication to perfection that ensures every dollop, every spoonful, delivers the exact same, satisfying experience. Prepare to uncover the secrets behind a culinary staple, to witness the precision that turns simple components into a global phenomenon. This is more than just a factory tour. It's an exploration into the very essence of what makes our food, our food. Mayonnaise. The word itself conjures images of picnics, sandwiches, and creamy salads. It seems so straightforward. Eggs, oil, vinegar, a pinch of salt. Yet, the journey from these basic components to the perfectly stable, deliciously tangy emulsion we know and love is a testament to both culinary art and advanced food science. It's a product so deeply ingrained in our culture that its origins are often overlooked, its complexities entirely underestimated. Consider the egg yolk, the unsung hero of mayonnaise. It's not just for flavor, it's the emulsifier, the molecular maestro that holds the oil and water together in a stable, creamy suspension. Without it, or a suitable substitute, you'd simply have a separated mess of oil floating atop vinegar. The lesser thing within the yolk, a phospholipid, acts as a bridge, with one end attracted to fat and the other to water. This seemingly simple biological compound is the key to preventing the emulsion from breaking, a challenge that plagued early attempts at commercial production. The concentration of lecithin in egg yolk is surprisingly high, making it one of nature's most effective emulsifiers, a fact that modern food scientists leverage to its fullest potential. Historically, mayonnaise was a delicate, temperamental creation, made by hand, dropped by a agonizing drop of oil into whisked egg yolks. The risk of it breaking, separating back into its constituent parts, was ever present, a source of frustration for countless chefs and home cooks. The industrial scale, however, demands absolute consistency and stability, requiring a level of control and understanding far beyond what was possible in a traditional kitchen. This is where modern food science truly shines, transforming a finicky kitchen task into a robust, repeatable process that can produce millions of liters of product with unwavering quality. Did you know that the exact origin of mayonnaise is a subject of culinary debate? While many stories point to Mahon, Menorca, in 1756, during the 7 Years' War, when the French Duc de Richelieu's chef supposedly invented it to celebrate a victory, the truth is likely far older and more complex. Similar emulsions existed in various forms across Europe long before this date, often under different names or as regional specialties. What is certain is that its popularity exploded in the 19th century, moving from aristocratic tables to more widespread consumption, largely thanks to advancements in food preservation and distribution, which made it possible to transport and store such delicate products. The Industrial Revolution, with its emphasis on mass production and standardization, further cemented mayonnaise's place as a global condiment. The sheer volume of mayonnaise produced globally is staggering. It's not just a condiment, it's a foundational ingredient in countless dishes worldwide. From the classic American potato salad to Japanese okonomiyaki, its versatility is unmatched. This global demand has driven incredible innovation in its production, pushing the boundaries of ingredient sourcing, processing technology, and quality control. The market for mayonnaise and mayonnaise-based products is a multi-billion-dollar industry, constantly evolving with new flavors, textures, and dietary adaptations. One of the most surprising aspects of industrial mayonnaise is the precision involved in its texture. It's not just about taste, it's about mouthfeel. The size of the oil droplets within the emulsion plays a critical role. Too large, and the mayonnaise feels greasy and unstable. Too small, and it can become overly thick, pasty, or even gluey. Modern factories employ sophisticated homogenizers that can create oil droplets as small as 1 to 5 micrometers. That's thousands of times smaller than a grain of sand, ensuring that silky, smooth texture we expect. This microscopic engineering is a far cry from the rustic whisking of yesteryear, where droplet size was largely a matter of chance and arm strength. The consistency achieved through these machines is a key factor in consumer preference and product stability. And what about the oil itself? While home cooks might reach for olive or sunflower oil, industrial production often utilizes oils chosen for their neutral flavor, high oxidative stability, and cost-effectiveness, such as soybean, canola, or corn oil. The quality and freshness of this oil are paramount, as rancidity can quickly ruin an entire batch, leading to off flavors and odors. Factories often have strict specifications for the oil's fatty acid profile, iodine value, and oxidation levels, ensuring a consistent, clean taste and extended shelf life. The sourcing of these oils is a global operation, with vast agricultural networks dedicated to providing the necessary raw materials. The vinegar, too, is more than just an acid. It contributes significantly to the flavor profile, providing that characteristic tangy bite, but crucially, it also acts as a natural preservative, lowering the pH of the mayonnaise to inhibit bacterial growth. Different types of vinegar, white distilled, cider, or even wine vinegar, can subtly alter the final taste, allowing for a wide range of product variations to suit diverse palates and regional preferences. This careful balance of acidity is a critical safety measure, ensuring the product remains safe for consumption over its shelf life, typically ranging from several months to a year when refrigerated. The pH target for commercial mayonnaise is usually below 4.0, a level at which most pathogenic bacteria cannot thrive. Beyond the core ingredients, industrial mayonnaise often includes stabilizers like starches or gums, e.g., xanthan gum, guar gum, antioxidants like EDTA, ethylenediamine tetracetic acid, and natural flavorings. These aren't just fillers, they are carefully selected to enhance shelf life, maintain texture consistency, and protect against spoilage or flavor degradation. For instance, EDTA, while sounding chemical, is a common food additive that binds to trace metal ions, preventing them from catalyzing oxidation reactions that could lead to rancidity and off flavors. It's a silent guardian of freshness, extending the product's appeal. Stabilizers, on the other hand, help to increase the viscosity and prevent syneresis, water separation, over time, ensuring the mayonnaise maintains its creamy consistency even after opening. The evolution of mayonnaise production also reflects broader trends in food technology and consumer demand. Early commercial mayonnaise, while a marvel for its time, was often less stable and had a shorter shelf life than today's products. The advent of pasteurization for eggs, improved mixing technologies, and sophisticated packaging materials have all contributed to the robust, long-lasting mayonnaise we find on shelves today. This isn't just about convenience, it's about food safety, reducing waste, and making a high-quality product accessible to a wider population. The development of aseptic processing and packaging has further revolutionized the industry, allowing for even longer shelf lives without refrigeration for certain types of mayonnaise-based products. Consider the challenge of producing mayonnaise without eggs for vegan alternatives. This requires an entirely different approach to emulsification, often relying on plant-based proteins, like pea protein or soy protein, starches, or hydrocolloids, like modified starches or carrageenan, to mimic the emulsifying properties of egg yolk. The development of these alternatives showcases the ingenuity of food scientists, who must understand the fundamental principles of emulsion stability and then find novel ways to achieve it using different ingredients, often with complex interactions. It's a testament to how deeply understood the mechanics of mayonnaise truly are, allowing for creative solutions to meet evolving dietary needs and preferences. These vegan versions often present unique challenges in achieving the exact same mouthfeel and stability as traditional mayonnaise, pushing the boundaries of ingredient functionality. The sheer scale of production means that even minor variations in ingredient quality or processing parameters can have massive consequences. A slight deviation in temperature, a fraction of a percentage difference in ingredient ratios, or an inconsistent mixing speed can lead to a batch that separates, has an off flavor, or fails to meet the desired texture. This is why high-tech factories employ continuous monitoring and automated adjustments, ensuring every single batch adheres to exacting standards. It's a constant dance between art and science, tradition and innovation, all to deliver that perfect dollop. The use of advanced sensors, artificial intelligence, and machine learning is becoming increasingly common, allowing for predictive maintenance and even more precise control over the entire manufacturing process, minimizing waste and maximizing efficiency. Furthermore, the environmental impact of mayonnaise production is a growing concern. Factories are increasingly adopting sustainable practices, from sourcing ingredients from environmentally responsible suppliers to optimizing energy consumption in their facilities. Water recycling, waste reduction programs, and the use of renewable energy sources are becoming standard practices, reflecting a broader commitment to ecological stewardship within the food industry. The packaging itself is also evolving, with a move towards more recyclable, biodegradable, or compostable materials, addressing consumer demand for more sustainable product choices. This holistic approach ensures that the mayonnaise not only tastes good but is also produced with a conscience. The journey of mayonnaise begins not on the factory floor, but far beyond its walls, in the fields and farms that supply its fundamental components. Raw materials arrive at the factory's receiving docks, a bustling hub where quality control is paramount. Large tankers deliver millions of liters of refined vegetable oil, typically soybean or canola, chosen for its neutral flavor profile and high oxidative stability. Simultaneously, refrigerated trucks bring in liquid egg yolk, often pasteurized and sometimes frozen, to ensure microbiological safety and extend shelf life. Vinegar, usually distilled white vinegar for its clean acidity, arrives in bulk, alongside large sacks of salt, sugar, and other minor ingredients like stabilizers and natural flavorings. Upon arrival, each raw material undergoes rigorous inspection. Samples of oil are tested for acidity, peroxide value, an indicator of rancidity, fatty acid profile, and clarity. Egg yolks are checked for bacterial counts, pH, solids content, and color. Vinegar is analyzed for acetic acid concentration and purity. Salt and sugar are tested for purity and particle size. Only materials meeting stringent specifications are accepted and transferred to vast, climate-controlled storage tanks, ready for their transformation. These tanks are often equipped with agitation systems to maintain homogeneity and prevent settling. This meticulous vetting process is the first critical step in ensuring the consistent quality and safety of the final product, preventing costly recalls and maintaining brand reputation. The manufacturing process itself is a marvel of continuous flow and precise engineering, designed for maximum efficiency and hygiene. It typically begins in the premix area. Here, the liquid egg yolk, along with water, salt, sugar, and any dry stabilizers, such as modified starches or gums, are carefully measured and combined in large stainless steel tanks. These tanks are equipped with high shear mixers that rapidly blend these ingredients into a homogeneous slurry, ensuring all solids are fully dissolved and the emulsifying agents from the egg yolk are fully dispersed and ready to perform their function. The temperature is often controlled at this stage to optimize ingredient solubility and prevent premature reactions or microbial growth. This premix is then often passed through a fine filter to remove any particulate matter, ensuring a smooth final product. Next, this premix is transferred to the main emulsification stage. This is the heart of mayonnaise production, a critical phase where the oil and water phases are brought together under intense mechanical energy. The premix is continuously pumped into a high-shear mixer or colloid mill, while the vegetable oil is simultaneously introduced at a precisely controlled rate. The magic happens here. As the oil is added, the intense mechanical energy from the mixer breaks it down into incredibly fine droplets, often in the range of 1 to 5 micrometers. The emulsifying agents from the egg yolk immediately surround these tiny oil droplets, forming a protective barrier that prevents them from coalescing back together. This rapid and thorough dispersion of oil in the water phase is what creates the stable, creamy emulsion. The ratio of oil to water, the speed of mixing, the temperature, and the residence time in the mixer are all meticulously controlled by automated systems, often using inline sensors to monitor viscosity, droplet size, and energy input in real time. This continuous process ensures consistent quality from the first drop to the last. Once the primary emulsion is formed, the vinegar is introduced. This is a critical step, as the acidity of the vinegar not only contributes to the characteristic tangy flavor but also lowers the pH of the mayonnaise, acting as a powerful natural preservative. The addition of vinegar is carefully managed to avoid shocking the emulsion, which could cause it to break. After the vinegar, any final flavorings, spices, or antioxidants are added and thoroughly blended, often in a secondary mixing stage to ensure even distribution without overshearing the delicate emulsion. The newly formed mayonnaise then moves through a series of stringent quality control checkpoints. Inline viscometers continuously measure its thickness and flow properties, ensuring it meets the desired consistency. pH sensors verify the acidity levels are within the safe and specified range, typically below 4.0. Temperature sensors monitor the product's thermal profile. Samples are periodically drawn from the line for comprehensive laboratory analysis, checking for microbial counts, total plate count, yeast, mold, coliforms, fat content, salt content, and sensory attributes like taste, texture, and appearance by trained sensory panels. Any deviation from the set parameters triggers an alarm, and automated systems can make minor adjustments to ingredient flow or mixing speeds to bring the batch back into specification. In severe cases, an entire batch may be diverted for further processing or disposal, highlighting the importance of these controls. From the emulsification stage, the mayonnaise is typically pumped through a cooling system. Reducing the temperature helps to stabilize the emulsion further, increases its viscosity, and prepares it for packaging. This cooling is often achieved using plate heat exchangers or scraped surface heat exchangers, ensuring rapid and uniform cooling without damaging the product. It's then transferred to large, sterile holding tanks, acting as a buffer before the final packaging lines. These tanks are often jacketed to maintain a consistent cool temperature and are equipped with gentle agitators to prevent any potential separation or skinning on the surface. The packaging process is highly automated and efficient, designed to minimize human contact and maximize speed. Conveyor belts transport empty jars, bottles, or pouches, which have often been sterilized, to high-speed filling stations. Precision nozzles, often volumetric or gravimetric fillers, dispense the exact amount of mayonnaise into each container, minimizing product giveaway. The containers then move to capping machines, where lids are applied and sealed, often with induction heat for tamper-proofing and extended freshness. Labeling machines apply product information, nutritional facts, batch codes, and expiration dates with laser precision. Vision systems often inspect each package for correct labeling and sealing. Finally, the packaged products are grouped, often by robotic palletizers, and shrink-wrapped or boxed for shipment. These finished goods are then moved to a temperature-controlled warehouse, awaiting distribution. Throughout the entire process, safety and hygiene are paramount. All equipment in contact with the product is made of food-grade stainless steel, which is non-reactive and easy to clean. The entire production line is subject to rigorous cleaning in place, CIP, protocols between production runs, where cleaning solutions and sanitizers are circulated through the system without disassembly. Air filtration systems, HEPA filters, maintain a clean room environment in critical areas, and personnel adhere to strict hygiene standards, including specialized clothing, hairnets, gloves, and mandatory hand-washing procedures. Hazard analysis and critical control points, HAC principles, are strictly applied at every stage, identifying potential hazards and implementing controls to prevent them. Every step, from raw material reception to final packaging, is designed to ensure the production of a safe, high quality, and consistently delicious product, meeting both regulatory requirements and consumer expectations. The factory is a testament to how precision engineering, advanced chemistry, and unwavering quality control converge to create an everyday staple. And there you have it, the hidden world behind that seemingly simple jar of mayonnaise. From the delicate dance of emulsification to the meticulous precision of high-tech machinery, it's a journey far more intricate and fascinating than most could ever imagine. Who would have thought that a dollop of this creamy condiment held so many layers of science, history, and engineering? The next time you reach for it, you'll see it not just as a spread, but as a testament to human ingenuity and the relentless pursuit of perfection in food production. If you were surprised by the microscopic engineering of oil droplets or the critical role of pH in preservation, imagine what other secrets lie hidden within the foods we consume daily. The world of food manufacturing is a constant source of wonder, full of unexpected challenges and brilliant solutions. Every product on our shelves has a story, a complex journey from raw ingredient to finished good, shaped by innovation and dedication. Don't miss our next deep dive into another fascinating factory. Click on the video that just appeared on your screen to journey inside a modern custard apple factory and discover the incredible processes that bring this unique fruit from farm to table. You'll be amazed at the technology involved in handling such a delicate and exotic produce. And if you enjoyed this glimpse behind the scenes, make sure to hit that subscribe button and ring the notification bell so you never miss an episode of our industrial explorations. We are constantly uncovering the marvels of modern manufacturing, bringing you closer to the products you use every day. What was the most surprising fact you learned about mayonnaise today? Let us know in the comments below. Your insights help us understand what truly captivates your curiosity.